So now let's ask ourselves, what happens if we threw a ball from a hill at different speeds? We're going to look at horizontal projection. We could look at vertical projection, but that's really simple. That's simply that, we have a particle and throw it upwards, what happens? And to be honest, we can do that really simply just by looking at these equations for the vertical case, and it's not really any different to the Suvat equations we've done so far. Horizontal projection is a bit more interesting. So we're going to ask ourselves, what happens if we throw a ball from a hill at different speeds? And I've done an illustration of that here. We can see we've got these are our balls, this is a hill, and these are the paths taken. We're going to ask ourselves, what happens? Well, it turns out there's a lot of stuff we can deduce straight away just from our principles of projectile motion and our equations we've come up with so far. So, not to labour the point, but the horizontal and vertical components are independent, which means that really the motion in the horizontal direction, which was what we're affecting by the different speeds we're throwing at, if we're throwing them horizontally, to be clear, it's horizontal projection, those are going to be different to each other, but that's not going to affect the vertical component, the height. So if we throw it from the same height each time, it's going to take the same time to reach the ground, regardless of whether it's this one being thrown a lot more strongly than this one. And you've seen I've drawn this below. You see that these both take the same time to hit the ground. They're projected from the same height. And even though one of them is just falling, and one of them is being thrown sideways, so one of them has some horizontal velocity, the other one has none. Because this horizontal motion is independent of the vertical motion, however we affect the horizontal motion, it's not going to affect the vertical motion, and therefore the time taken to reach the ground will be the same for both of them. That actually means, very interestingly, if you drop a ball and throw a ball, so throw a ball horizontally and drop a ball, they both reach the ground at the same time, which you might think of being as counterintuitive because we see this, this motion in this direction and assume maybe it should take longer because it's moving horizontally, but that's just not true at all. We've really completely divorced the vertical motion from the horizontal motion. And the vertical motion, if we're throwing it from the same height, is the same for each one, each time, regardless of whether it's this one being thrown really strongly or this one not strongly at all. This one, which is fairly obvious, the next point, but still need to be said.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level physics videos, just click the Snap Revise smiley face. Join me today, and together let's make A-level physics a walk in the park.